We are going to find the shortest path using Dijkstra's algorithm. So first the graph is given. This is a undirected graph. Even we can do for directed graph also. So first I have to create a table. So the table includes vertex, distance and path. So vertices means what are the vertices? A, B, C, C, D, E. So we are going to note A, B, C, D, E. So I am going to take my initial starting vertex as A. So the distance of A from A is usually 0. So note it as 0, and the path is also just note as 0, and others you mark as other distances you mark as infinity, because we are not knowing what is the distance. And the path we just put a hyphen. Okay, now we are going to mark this initial in the graph. So the initial distance of A is 0, others are infinity. So I am just going to mention it in my graph. So this will be our step 1. So step 2 is I am going to take A as known. Okay, if A is known, what are the adjacent vertices of A? So start from A and note the adjacent vertices. So from A you are having B and then D. From B, A to B and D. Now A to B, the distance is 0 plus 6, it is a 6. A to D, 0 plus the distance 1, it is 1. So the distance from the start A to D is 1. A to B is 0 plus 6, 6. So these changes we are going to update in our table. Since A is taken as known, I am just going to strike out this A. This is for our understanding we are doing. I am going to strike out this A. Next we are going to update the changes in the table. So A's distance is 0, so path is usually 0, that we will note. Then B's value is 6 from A. D's value is 1 from A. So other values we just write it just like that. So this is my second table. Next step we are going to take. So from this table we are going to find out which is the minimum. Now 1 is the minimum distance here. So next we are going to take D as known. Mark D as known. So here we are going to mark D as known. So I am going to first draw the picture. Going to mark D as known. D as known. Now we are going to see the adjacent vertex of D. A is an adjacent vertex, but it is already marked as known. So now we can't change the value. And next we are going to B. So now we are going to add the value 1 plus 2, that gives a 3. Here it is, the distance is mentioned as 6, but 3 is lesser than 6. So we are going to remove the 6 and change it into 3. Then 1 plus 1 is 2. Now we will make these changes in the table. B's value is 3 from the node D. Since D is known, we are going to make the path as D. Then E's value is 2 from D. So others we are going to just note it from the previous table itself. Okay, the next step is I am going to take the minimum of this. Okay, the minimum is E is the next minimum. So you are going to take E as known. E is known. So mark E as known. Now we are going to check the distance. From E, we can go to D, but D is already known, so you no need to change it. So leave it. Then from E, you are going to B. So here you are already having a E value of distance of 2. 2 plus 2 will give 4. But this is the minimum. 3 is already there and it's a minimum. So no need to change the 3, just leave it. Next from E, 2 plus 5 is 7. So it's not marked, it's just infinity earlier. So you are marking it as 7. Okay, now we are going to update the distance in the table again. We are going to make the changes. The only change we are making is C's value is 7. Mark B as no. So from B again we are going to see the adjacent vertex. A is the adjacent vertex, but all the distances you can see here the distances A is already marked, so no need to change it. From B you can go on to E also, D also, it is already known, so no need to change it. B, then you are going to E is already known, so no need to change it. Then from B, 3 plus 5 is 8, but already here it is a minimum, so no need to change this 7, let it be just like that. So we are going to update the table, and as you can see here there won't be much changes in the table. Mark C as known. Shortest path how to write is, so we started from A, right? So from A till all the other nodes, what are the other nodes? From A you can go to B, from A to C, A to D and A to E. We are going to write the distance. So B's values distance is given as here 3, C 7, D 1, E 2. So this is the shortest path from the source vertex